Hello guys, welcome back to my channel. So in this video I am going to explain you logistic versus linear regression, hypothesis, parameters and cost function and gradient descent. So let's get started. I am going to explain you this topic with the help of a question. So let's go. So the question is differentiate logistic regression and linear regression. So we have to differentiate the logistic and linear regression on the basis of hypothesis, parameter and cost function, and how gradient descent algorithm is used to optimize the parameters. So here is the quick overview of linear regression. So linear regression is used for predicting continuous values. Hypothesis: h x is equals to theta 0 plus theta 1 into x1 plus, and this is done at n times. So parameters: theta, weights representing linear relationship. Goals: minimize squared error between predictions and actual values. Now here is the quick overview of logistic regression. So logistic regression used for binary classification. Hypothesis: its hypothesis formula is hx is equals to sigma into theta to the power tx, where sigma z equal to 1 divided by 1 plus e to the power minus z. So here are the parameters: theta, weights of classification boundary, output is probably between 0 and 1. So when we calculate the output, so it is between 0 and 1. So here is the cost function comparison. So linear regression cost function: mean square error MSE, which we called MSE. So j theta is equals to 1 divided by 2m summation of hypothesis, which is h into x dash minus y dash whole square. Now logistic regression function: so cross entropy loss, j theta is equals to minus 1 divided by m summation of y dash log x dash plus 1 y dash log 1 minus h into x dash. Logistic regression cannot use MSE because sigmoid plus MSE causes non-convexity. So here is gradient descent optimization. Gradient descent updates parameter to minimize cost function. Update rule: here is the rule. So theta is equal to theta minus a into sigma j theta divided by sigma theta. A is equals to learning rate, control learning rate, which is control step size, continues until convergence, or we can say cost stops decreasing. So now we will discuss gradient descent in both models. So for gradient descent for linear regression is derivative uses linear hypothesis, convergence is smooth because cost is convex. Gradient descent for logistic regression: derivative includes sigmoid function, cost function is convex, gradient descent works efficiently. Both use same update rule but with different cost and hypothesis. So here is the conclusion: linear continuous output, linear gives always continuous output, and logistic gives classification. Hypothesis: linear versus sigmoid transformation, cost MSE versus cross entropy. Gradient descent is key for optimizing weights in both models. Thanks for watching guys. If you like this video, then hit the like button, and if you have a doubt you can just ask me in comment section, I will reply you.